Hi, in this video, we are going to look at a very interesting problem. You should pay attention to this video. It is a difficult problem, but you will learn a lot by solving it. So let's get into the question. The question says, f from R to R is a twice differentiable function satisfying the condition, satisfying f double dash x minus 5 times f dash x plus 6 times f of x is greater than equal to 0 for all x greater than equal to 0. If f of 0 is 1 and f dash of 0 is 0 and f of x also satisfies the inequality f of x is greater than equal to a times h of b of x minus b times h of a of x for all x greater than 0 for some function h of x, for some unknown function h of x. Then we have to find the value of a plus b times h of 0. Okay, so slightly strange type of question. You might not have seen this before. F is a real valued function which satisfies this equation, inequality. So this is a differential inequality. Here you have a double derivative, you have a single derivative and the function itself. And this is satisfied for all x greater than 0. They have also given f of 0 is 1 and f dash 0 is 0. And now they are saying that this function f of x satisfies another inequality. F of x is greater than a times h of b of x minus b times h of a of x for all positive x for some unknown function h of x. Basically, you have to get an inequality on f, right? And that will come in terms of a new function h. And finally, you have to find out this new function, right? So let's think about how we approach this problem. Okay. So it's a nice problem and it's a unique type of problem. So pay attention. You can try the problem yourself first. See if you can make any progress. And if not, you can follow this video. So we start off by thinking about this differential inequality, right? So we have f double dash x minus 5 f of x, f dash x plus 6 f of x is greater than equal to 0. So here, notice that 5 can be split in groups of 2 and 3. So what I will do is f double dash x minus 2 f dash x will be greater than equal to 3 times f dash x minus 6 times f of x. Why did I group it like this? Because then I can factorize it, at least like I can see that left hand side will be in a certain form and this side is 3 times f dash x minus 2 times f of x, right? Notice that this is in the same type of form, right? So we are getting something like this, f double dash x minus 2 times f dash x is greater than 3 times f dash x minus 2 times f of x, right? Now this should give you a hint because if you see the bracket here, the derivative of this is actually the left hand side, right? So you can see that f double dash x minus 2 f dash x is the derivative of this, right? And this inequality, by the way, is true for all positive x greater than equal to 0. So this is also true for all x greater than equal to 0. So let's do it on the next screen and see what we can do here. So we have f double dash x minus 2 times f dash x is greater than equal to 3 times f dash x minus 2 times f of x for all x greater than equal to 0. So what I will do is I will take a new function, take gx to be equal to f dash x minus 2 times f of x, right? Why is this better for us? Because now I can write this inequality as g dash x is greater than equal to 3 times g of x, right? And this is true for all x greater than equal to 0. I hope you have understood so far. We have just called this as g and this is my g dash x. So now this can be represented like this: g dash x minus 3 times g of x is greater than equal to 0. Now this is a standard linear differential equation. Like you can see, this is the form of linear differential equations, right? Here, if you multiply by integrating factor of e power integral px dx, what will happen is the left hand side will become y times e power integral p dx is equal to q into e power integral p dx, integral of, right? This is the solution of the differential equation, right? And it comes because if you multiply both sides of it by this integrating factor, then the left side is basically the derivative of d by dx of y into e power integral p dx. And the right side is simply q into e power integral p dx, right? So that is the standard theory of how to solve a differential equation which is linear and like this, right? We have to multiply by integrating factor and left side becomes the derivative of y times integrating factor, right? So we will do the same thing here, because here you have d of g by dx plus minus 3 into gx greater than equal to 0. So minus 3 will be my p of x. So integrating factor here would be e power integral minus 3 dx. So it is e power minus 3x, right? And if I multiply both sides of it by this e power minus 3x, I will get e power minus 3x g dash x plus e power minus 3x into minus 3gx is greater than equal to 0, right? You should realize by the same method that the entire left hand side is the derivative of g of x times integrating factor. So you can say d by dx of g of x times e power minus 3x is greater than equal to 0. Think about it. I'm following the same method that I do for normal linear differential equations. I'm just multiplying by integrating factor and writing the left side as the derivative of this. The derivative of this would be g dash x e power minus 3x, this first term, and g of x e power minus 3x into minus 3, right? So you should be convinced that this is coming, and this is true for all x greater than equal to 0, right? Okay. So from there, what can we conclude? So far what we have seen is d by dx of gx into e power minus 3x is greater than equal to 0 for all x greater than equal to 0. And here gx was what? Gx was f dash x minus 2 f of x, right? So from this statement, we can say that gx into e power minus 3x is a non-decreasing function. Non-decreasing function. So either it is going to increase or it is going to remain constant for all x greater than equal to 0, right? So if it is a non-decreasing function, then let's think about the values of this function. So you can say, what is g of 0? If you put 0 here, g of 0 in this was what? F dash 0 minus 2 f of 0. But remember, in the problem, they have given you the values of f dash 0 and f of 0. So it is going to be 0 minus 2 into 1, according to the data in the question. So g of 0 is minus 2, right? So therefore, g of 0 is negative, and therefore g0 e power minus 3 into 0 would be basically minus 2, right? In this function, if I put 0, the value will come out to be minus 2. but it is a non-decreasing function for all x greater than 0. So for any other x, for any x greater than 0, I can say that gx into e power minus 3x will be greater than the value of g of 0 into e power minus 3 into 0, right? Which is equal to minus 2. So you should be able to make the claim that gx into e power minus 3x is greater than equal to minus 2 for all x greater than equal to 0. I hope you are understanding what I have done so far. Because this function is non-decreasing and the value at 0 was minus 2, therefore we can say that after that the values will increase, right? So it will be greater than equal to minus 2. So that is one inequality that I have gotten at this stage, right? So let's see what we can do with this. So far we have gotten g of x into e power minus 3x is greater than equal to minus 2 for all x greater than equal to 0. And we already know that g of x is equal to f dash x minus 2 f of x, right? So what I will do is I will write this in a different way, multiplying both sides by e power 3x because it's a positive quantity. I get this. I have multiplied both sides of this inequality by e power 3x. I get this relation. And now I can write it as f dash x minus 2 times f of x is greater than equal to minus 2 e power 3x for all x greater than equal to 0. Why? I'm putting instead of gx, I'm putting its original meaning, right? Okay. Now notice that this expression is again a linear differential inequation, an inequality, right? And I will use the same method that I used before. I will multiply by the integrating factor. So here you should realize that this is d f of x by dx plus minus 2 times f of x greater than some q of x, right? So the integrating factor is simply e power integral minus 2 dx. So e power minus 2x, right? If I multiply both sides of this equation by e power minus 2x, I will get something like this. E power minus 2x f dash x minus 2 e power minus 2x f of x is greater than equal to minus 2 e power 3x multiplied by e power minus 2x, right? This is what I'm getting. And notice that the left hand side, just like before, is the derivative d by dx of y times integrating factor. So it is f of x times e power minus 2x is greater than equal to, this is coming as minus 2 e power x, right? So I'm getting this result right now. D by dx of f of x e power minus 2x is greater than minus 2 e power x, right? So let's see what we can do there. We have d by dx of f of x e power minus 2x is greater than equal to minus 2 into e power x. So this is true for all x greater than equal to 0, right? And this left hand side can be written as minus 2 times derivative of e power x because derivative of e power x is e power x only. So it can also be written as derivative of minus 2 e power x, right? Why am I writing it like that? Because I wanted to bring it on the one side and say that it is whole thing is greater than 0. So what I will do is d by dx of f of x e power minus 2x is greater than equal to d by dx of minus 2 e power x. And now I will bring everything on one side. D by dx of f of x e power minus 2x minus of this. So it will be plus 2 e power x is greater than equal to 0. What have I done here? I have brought this term to this side with a minus sign and then combined it and written it as one derivative, one single derivative, right? So basically what we get from here is this thing's derivative is greater than 0 for all x greater than 0. So what that means is this function f of x into e power minus 2x plus 2 e power x is greater than equal to 0 or is non-decreasing. the derivative of that function is greater than equal to 0. So we can say that this function is also non-decreasing for all x greater than equal to 0, right? So now we are coming to the end of the problem. We have almost gotten it, right? So if it is non-decreasing, then let's put the value at 0 and see what is the lower value of it. F of 0 e power minus 2 into 0 plus 2 into e power 0. So this is becoming f of 0 was 1. So this is also 1, this is 2. So this is whole thing is equal to 3, right? This is the value of the function at 0. So we have f of x e power minus 2x plus e power 2x is non-decreasing for positive x, right? And now we already know the value of the function at 0. So we can say that for any x greater than 0, f of x into e power minus 2x plus e power 2x will be greater than 3, right? You should realize that it will be greater than, or you should put an equal to sign also, and let's say equal to. So this has to be true because the derivative of the derivative of this function was positive or 0. So it was never going to be lesser, right? So as you go at a value x bigger than 0, your value of the function here will be bigger than 3, which is the value at 0, right? So once we get this, I can simplify it a little bit. F of x e power minus 2x is greater than equal to 3 minus e power 2x. Multiply both sides by e power 2x. So f of x is greater than 3 e power 2x minus e power 4x. Wait, I have made a mistake somewhere. I have made a mistake here, a writing mistake. This was not e power 2x, this was 2 e power x, right? This was the previous function. Here I had put 2 e power 0. So it's not e power 2x. That is a writing mistake, silly mistake on my part. This is 2 e power x here. And I will do it again. So we are getting f of x e power minus 2x plus 2 e power x is greater than equal to 3. So f of x e power minus 2x is greater than equal to 3 minus 2 e power x, and f of x will be greater than equal to multiplying both sides by e power 2x, 3 e power 2x minus 2 e power 3x, right? So notice that we are getting this, and this is true for all x greater than equal to 0, right? So now we are at the end because the question had said that f of x was supposed to be greater than equal to a times h of bx minus b times h of ax, right? And this was supposed to be true for all x greater than equal to 0. And what I have gotten is 3 e power 2x. So clearly a is 3, b is 2, and h of x is e power x, right? You can see from here that we are getting h of x is e power x, a is 3, b is 2, and then we are getting a relation which looks exactly like this. A times e power 2x minus b times e power ax, which is 3x, right? And therefore the answer will be a plus b h of 0 would be simply 5 into e power 0, which is 5. And that finishes off the problem. So the idea for the question is to start with the initial double derivative inequality and write it like this. This was our initial inequality. What I did was just wrote it like this, f dash x minus 2 f dash x, and took the 3 f dash x on this side minus 6 fx this side. And I can see here that it is g dash x is greater than equal to 3gx, where g function is f dash minus f minus 2f, right? Once you get this, you have something like this, g dash x minus 3g is greater than equal to 0. Multiplying by the integrating factor, I can say d by dx of g into e power minus 3x is greater than or equal to 0, which means g into e power minus 3x is non-decreasing. The value of g at 0 is minus 2. So we can say that g of x e power minus 3x is greater than or equal to minus 2. Once we got this, I did simple stuff. I said g of x is greater than or equal to minus 2 e power 3x. And I wrote g of x as f dash minus 2f is greater than minus 2 e power 3x. And I repeat the same thing. I multiply it by the integrating factor. In this case, it is e power minus 2x now. Once you do the integrating factor stuff, you will end up with a situation where you will have derivative of f of x into e power minus 2x is going to be greater than or equal to minus 2 e power x. So combine, this can be written as a derivative also of minus 2 e power x. You combine everything and you get that d by dx of f into e power minus 2x plus 2 e power x is always greater than or equal to 0. So if this function is a non-decreasing function, the value of this function at 0 was coming out to be at 0 it was f of 0, so it was 3. So this function is always going to be greater than or equal to 3, and then you just simplify it and get the value of the hx and the a and the b. So hopefully you've learned how we use the concept of integrating factor to solve this inequality. So that should be clear to you now, and I'll see you next time in the next video.